So in the second of our Introduction to Chemistry videos, we're going to look at writing different types of chemical formula. So we're going to start with molecular substances, so they're covalently bonded substances, and we're going to move on to ionically bonded substances, and we're going to look at the different types of formulas that we've got to be able to write. So for molecular substances, there's a bit more memory work. There's not as much working out, it's more to do with remembering the formula. So one of the things I want you to try to remember is the formulas of all the diatomic elements to know whether they're going to exist as diatomic or monatomic going around on their own. So if you look back to the video on the periodic table, you should be able to remind yourself about the formulas of the elements. So on the left hand side here we've got elements, and on the right hand side we've got some compounds, but these are all molecules, so all bonded in some way. So oxygen is one of our diatomic. Have no fear of isophobia, this is the of in the diatomic elements rhyme. Hydrogen, H2, chlorine, Cl2, nitrogen, N2. There's only two other diatomic elements that there are. One of them is here, bromine, and the last one would be fluorine. And then just if you remember, we recalled when we were looking at our periodic table that phosphorus is another element that goes round, but this time in fours, P4, and there was one more. If you want to stick that on the bottom, you could add sulfur onto the bottom here as S8. And we had that one remaining diatomic element, fluorine, F2. So there are elements that are molecular. What about our compounds? So we've got water. Hopefully everybody knows the formula of water is H2O. What's the formula CO2 for? Well, we should all know that that's carbon dioxide. NH3 is ammonia. And that end of that word is quite important because we're going to come across something called ammonium later with a different formula. Ammonia, NH3. CH4 you will have used at school, that's methane. If carbon dioxide is CO2, carbon monoxide, mono meaning one, is CO. And sulfur trioxide, tri meaning three, is SO3. Sulfur dioxide would be SO2. You need to learn these formulas. What about the acids that you might come across? So pause the video now and see how many of these acids you actually know from the top of your head. There you go. So we would hope that you would know the formulas of hydrochloric and sulfuric acid, but perhaps you are not as familiar with nitric HNO3. Phosphoric acid, again, not as commonly used at GCSE, so you might not be familiar with that, but that's H3PO4. So make it a priority to learn the formulas of these acids. You might want to, for now, write those formulas onto your data sheet that you carry around with you at all times, so that you've got them there handy if you were to forget them. Okay, so maybe write those down on your data sheet. We're going to move on. We're going to have a look at the formula of some ions. Now, when we were looking at our periodic table in an earlier section, we did mark on the charges of these ions on our periodic table, but group 1 metals lose one electron to become 1 plus ion. So some examples of that would be sodium becomes a sodium plus ion, lithium becomes a lithium plus ion, potassium becomes a potassium 1 plus ion. Group 2 metals lose 2 electrons. Their 2 outer shell electrons become 2 plus ions, like magnesium, calcium, barium. Those things in group 7, they're non-metals, they gain 1 electron to get a full shell of electrons. So we're talking things like chlorine becoming the chloride ion, bromine becoming the bromide ion, iodine becoming the iodide ion. Notice that for positive ions, we don't change the name, so sodium becomes a sodium ion, we just say sodium ion, magnesium becomes a magnesium ion, but for the non-metals, chlorine becomes chloride. Now when it ends IDE, it means it's a negative ion of the element. Chloride, bromide, iodide, Group 6, oxygen becomes oxide, and they become 2- because they gain 2 electrons. Sulfur becomes sulfide. So sulfide, S2-. Now you might have heard of sulfate at school. You might have used copper sulfate. When it says ATE, it's not just one element. It's made of sulfur and oxygen, sulfate. So sulfide is just sulfur, and sulfate is sulfur and oxygen. And then there's the little section in the middle of the periodic table that's a little bit confusing because it's not in a group, so you think, how many electrons does it lose? And the reason those metals in the middle are there is because they can form more than one stable ion. They can lose different numbers of electrons and form stable ions. And so we're going to use Roman numerals. If you aren't familiar with the Roman numerals up to 7, you need to practice the Roman numerals. We've got I, IV, V, VI and VII. You just need to be able to go to 7 in A-level chemistry. Copper 2 is telling us, the 2 in Roman numerals is telling us that the charge on copper is a 2+. Iron 3 is telling us that the charge on iron is Fe3+. And when we see the Ni2+, we would write that it is a nickel. That's what the symbol Ni is for, and then we'd write 2 in Roman numerals, and then the word iron. The Roman numerals are always positively charged numbers because the transition metals only form positive ions. Metals always lose electrons to form positive ions. Then we're going to need to learn the formula of some compound ions. Remember that the definition of a compound is 2 or more different atoms chemically joined. These ions are made of 2 or more different atoms chemically joined. All of these compound ions you need to know the formulas of. So again, if it's going to help you, you could write them onto the front of your data sheet. There's a big empty space on the front of the data sheet. You could write these on so that you never forget them. We've got the only positive one you need to know. It's called the ammonium ion. If you remember in a previous section I highlighted ammonia and made a point of saying ammonia. Now we've got ammonium, and now it's NH4+. Ammonia is NH3, ammonium, NH4+. We've got hydroxide, nitrate and hydrogen carbonate. They're all 1-. Then carbonate, which is 2-, and sulfate and phosphate, which is 3-. You've got to learn these. So how would you put all that information together to work out the formula for an ionic compound? Remember, we've learnt the formula for our covalent compounds. We can work out the formula for our ionic compounds. So you read the name. We've got a name here, magnesium chloride, and you write down the formula of the 2 ions. So magnesium. You say to yourself, well, magnesium, it's in group 2 of the periodic table, and therefore I know it's going to form a 2+ ion. And then chloride comes from chlorine. Chlorine is in group 7 of the periodic table, and things in group 7 form a 1- ion. Now you balance the charges. There needs to be the same amount of positives as there are negative. So to do that, we've got 2 pluses, we're going to need 2 minuses. So we'll need 2 chloride ions to balance a magnesium. We're going to have MgCl2. And that 2 comes down there as a subscript, 2 chloride ions. So pause the video and see if you can work out the formulas of each of these 3 ionic compounds. Here you go. Sodium is in group 1, so sodium 1+, iodide is 1-, 1+ and 1- balance, so the formula is just NaI. Calcium is in group 2, so it's 2+, and fluoride is 1-, so I end up with CaF2. Aluminium is in group 3, and oxide is in group 6, so I've got a 3+ and a 2-. Now to make those balance, I'm finding a common multiple, and the common multiple is 6, so 2 3s make 6, and 3 2s make 6, and we're balancing out the charge. Al2O3, aluminium oxide. Now what we need to do is watch out for those compound ions, those ones that we've had to learn, can't use the periodic table to find. So if we were doing this, we'd go copper 2, so the Roman numerals tells us about the copper, and sulfate we have to memorise is a sulfate ion is an SO4 2 minus ion. And then we check if the charges balance. And they do, so we write CuSO4. So again, pause the video, have a go at these 4 here, see if you can work out their formulas. Okay, so if we have a look at those, sodium carbonate, Na2CO3. Now notice on this ammonium one, we've got an ammonium ion which is 1 plus and the sulfate is 2 minus. So we need 2 ammonium ions to balance the sulfate, but we can't write NH42, we have to have 2 of the N's and 2 lots of the H4 as well, so we have to put it in brackets. When we've got a compound ion with more than 1 atom and we want to double it, then we need to put that in brackets. Similar thing happening here with the magnesium hydroxide, 2 hydroxide ions. And again, with the hydrogen carbonates, I need 2 hydrogen carbonates. Often students make a mistake here and they think they have to put calcium and then they have to try and work out hydrogen and then they have to try and work out carbonate. Ionic compounds are made of 2 ions, a positive ion and a negative ion, so you just need to find the positive ion, calcium, and everything else is the negative ion, hydrogen carbonate. Magnesium is the positive ion, hydroxide is the negative, ammonium is the positive, sulfate is the negative. Okay, so you just need to be able to figure out the positive and the negative and put them together, balancing the charges, using brackets where needed.